Alright, welcome back to another episode. In this one, we'll be doing the Redix Sort Algorithm. So, as always, we'll start from the practicals, then we'll move on to we'll start from the theoreticals and then we'll move on to the practicals. In theoreticals, we'll do the definition, we'll do the steps, and we'll understand the advantages and disadvantages of using this particular algorithm. So, without wasting our time, let's get into it with the definition. Alright, so let's take a look at the definition. Radix sort, obviously a non-comparison based sorting algorithm, just like the last one we did, counting sort, right? So this basically efficiently sorts integer by processing individual digits. It is particularly useful when it comes to sorting numbers with a large number of digits. So when it comes to like sorting a number which has maybe let's say 8 digits, 10 digits, 12 digits, it's really useful. And it can also work with data types like string. That's really great. And one more interesting thing, unlike other comparison-based sorting algorithms, Radix sort sorts the data by exploiting the properties of digit positions. This is an interesting one. Alright, so let's move on to the steps of how do we actually even perform the Radix sort algorithm. Okay, let's move on to the steps. Step number one, find the maximum number. You have to first determine the maximum number in the way to identify number of digits used or needed for sorting. Second, sort by each digits. Start sorting from least significant digit, which is LSD, to the most significant digit, which is MSD, using a stable sorting algorithm such as counting sort or any of these things. But all you have to do is just sort by each digit for each digit positions, right? And then iterate through digits. Simple as that. The third step is iterate through digits. Repeat the sorting process for each digit's position until the entire number is sorted. That's how it works. Simple as that. Let's take a look at the advantages. Efficiency, non-comparison, obviously, counting sort, stability, adaptability, and predictable performance. You can predict the performance in real time. You just actually can do that. And how you basically do that? Because of the consistent time. Radix sort's performance is predictable with consistent time complexity across different data sets. So now what are the disadvantages of using the Radix sort? So the first one, space complexity, as usual, limited data types, okay, range and digits, obviously, pre-processing requirements, there are quite a bit, like converting the data types or normalizing the ranges. And then there are not in place, like extra storage. The algorithm uses the additional storage, making it less space efficient compared to in-place sorting algorithms. So we're done with the disadvantages too. So let's just move on to the coding part and see how does this actually work. Let's do that. So we are back onto our coding screen. So as I said earlier, that we need any kind of algorithm, just like a counting sort, to sort the data that we can further use for Radix sorting. So what we're gonna do is just take the counting sort algorithm entirely to use it inside of this particular program so that we can perform Radix sort algorithm. So let's just do counting sort again. So things are pretty simple up here. Up here we have to just create an output array that will have the sorted array. Then what we do is initialize the count of the array with 10, which makes the array size of 0 to 9. All right. Then what we do is just store the count of occurrence of each digit in the count array. Okay, pretty simple. Then the next move will be pretty damn straight. Change count of I so that it contains the position of the digit in the output. That's it. That's all of it. Then we have the last step, as you already know, build the output array. And then you're just done with counting sort. All right. So let's just do that. Okay. While this then index equals to of I slash exe, then output of count of index modulus 10 minus 1. I totally remember this stuff. It seems like I think I've memorized, or I think I've conquered the entire game of this, because I understand this so deep rootedly, because this is deep rooted inside of me. So I've done this multiple times. All right, once you're done with that, just copy the output array to array. Okay, and we're done. So once you're done, just define the Radix sort algorithm. So create a function calling it a Radix sort. Inside of that, pass the function arr. All right, so what we do is just create the function Radix sort, pass the array, and then find the maximum value of the particular array. And then once we're done with finding the maximum value, all we have to do is apply counting sort for every single digit that we have. That's it. That's all we do. And once you do that, you have your totally sorted array done. We don't actually have to return the array or maybe print the array. It will just sort the array, and then you can print the array again, and it will be sorted, right? So let's just do that. Okay, so I guess okay, we are done. Perfectly fine. So now all we have to do is just create an array and then let it sort, and things will be completed after. Okay, so create an array real quick, then say call Radix sort, and inside of Radix sort pass the array, and then just print the array. All right, done. So you'll have a perfectly well defined sorted array. All right, so see you in the next one with some new algorithm. Till then, keep improving, keep impressing.